Okay, so I divided section 3 up into 2 different videos so you didn't hear me talk for like 45 minutes straight. That section on erythrocytes is a really long section. So the second half of this section is going to really just talk about the different types of disorders that we have related to our red blood cells. My recommendation to you is to make flashcards for these and have a general idea of which each one of these disorders are. Most of the erythrocyte disorders are either going to be an anemia or a polycythemia. When we're talking about anemia, what it's referring to is some component of our blood has a low oxygen carrying capacity, low enough that it's not providing enough oxygen to support normal metabolism, meaning cellular respiration to produce ATP. A lot of times, if you do have anemia, regardless of which type of anemia you have, your symptoms are going to be a lot of fatigue and even chills and things like that. So we have 3 groups of anemia, and it's based off of the cause. So we can have anemia based off of blood loss. We can also have it as a result of not enough erythrocytes being produced to begin with, or because we have too many erythrocytes being destroyed prematurely. So we'll talk about blood loss. So hemorrhagic anemia, this means that we're losing huge amounts of blood very quickly, so hemorrhaging a lot of blood. So if you have some sort of severe wound, this would be hemorrhagic anemia. So the only way to really treat this is to, as quickly as possible, replace the blood that is being lost. You can also have chronic hemorrhagic anemia, so you have not a huge amount of blood being lost, but a small amount of blood being lost consistently. So something like an ulcer that you may have internally that's causing internal bleeding, even though it's a small amount, over time it's creating a significant blood loss, or even hemorrhoids. So when we're talking about chronic hemorrhagic anemia, you really want to go to prevent that small but persistent cause of blood loss. Most of our erythrocyte disorders are going to be the result of not producing enough erythrocytes to begin with. So one could be because you don't have enough iron. So iron deficiency anemia. If you have iron deficiency anemia, your erythrocytes that you're producing are going to be much, much smaller. So we refer to them as microcytes. They're small and pale in color because they cannot synthesize hemoglobin because they don't have the iron there to generate it. So how do you treat iron deficiency anemia? You start taking iron supplements. The other type is going to be pernicious anemia. And this is really going to mostly affect the elderly. It is considered an autoimmune disease, and it's going to destroy a lot of the stomach mucosa. When we hit the digestive system, you'll learn one of the really important functions of your stomach mucosa, and really the only essential function of your stomach at all, is going to be the production of something called the intrinsic factor. Intrinsic factor is required in order to absorb vitamin B12. We mentioned vitamin B12 earlier and how it is needed in order for our erythrocytes to undergo the developmental pathway and to divide. If we don't have B12, then our erythrocytes are going to become really, really, really large because they can't undergo cellular division. And so in this case, we would produce something called a macrocyte because of its large size. Treatment, fix what's missing, some sort of injection of vitamin B12. A lot of times pernicious anemia, I said it's typically going to affect elderly, but it can also be problematic for vegetarians and vegans because a lot of the B12 that we need, we actually get from meat and poultry and fish. So still going under the trend of, again, not having enough erythrocytes being produced, one could also be considered renal anemia. We talked about the hormonal regulation of erythrocyte production by EPO. So if we don't have enough EPO, or our kidneys cannot produce enough EPO, that's usually the result of some sort of renal or kidney disease. So what's the treatment? You would need some sort of supplement or injection with synthetic EPO. Another disorder is going to be aplastic anemia. So we can't produce enough erythrocytes because we have some sort of disruption at our red bone marrow. It can be caused, or is usually caused, by drugs and chemicals, but other things like consistent radiation or even viruses can cause destruction of our red bone marrow. But in the event that you have aplastic anemia and you have now inhibited all of your red bone marrow, not only have you limited the availability to produce erythrocytes, but all of your formed elements, because they're all originating from hematopoietic stem cells in your red bone marrow. So if you have aplastic anemia, you're going to have issues with production of erythrocytes, leukocytes, and your platelets. So typically, if you have aplastic anemia, you would need some sort of transfusion for whatever cell types that you need. And long term, in order to be more efficient with treatment, would actually be stem cell transplantation. Okay, so those disorders that we just talked about we're not producing enough erythrocytes. We could have, on the other hand, an anemia that's resulting from too many erythrocytes being destroyed. So this can be caused by incompatible blood transfusions, which we'll talk about at the end of this chapter, or we could have some hemoglobin abnormalities. So we have thalassemias and sickle cell anemia, which again, we have too many erythrocytes being destroyed. So thalassemias is typically found in people of Mediterranean ancestry, and it is a genetic disorder. So you have one globulin chain that is either absent or faulty. So typically each hemoglobin, again, has the 4 globulin chains. If you are missing one or it's not working correctly, then you're carrying 25% less oxygen than a typical healthy person's hemoglobin is. So you have really thin and delicate erythrocytes. There's different subtypes, and it really does range in severity from mild to extremely severe. If it is a really severe case, then you would require monthly blood transfusions. Sickle cell anemia, this is also genetic. So we have a mutated hemoglobin. Our globulin chains are 146 amino acids in length, and we only have one incorrect amino acid that's going to cause sickle cell anemia, and I have a picture of it on the next slide there. But sickle cell anemia is going to cause your erythrocytes to become crescent-shaped when your oxygen levels are low. So for example, during exercise, or if you're at a really high altitude, something like that. Another downside to sickle cell anemia would be that the sickling shape of the erythrocytes are going to cause it to really rupture easily, and they can also cause them to block small blood vessels, which again is going to lead to low oxygen delivery to tissues. So this is actually showing you over here that this is the amino acid here, glutamic acid, so amino acid number 6 in a chain of 146 amino acids, has been changed to a valine. And this one change in an amino acid can cause sickle cell anemia. So it's pretty crazy that something so small can cause something so significant. There is or has been shown to be some possible benefits to having sickle cell anemia in areas where malaria is prevalent. So malaria kills about 1 million people each year. Usually about 250 million people are infected. And if you have, and again, it's genetic component, so if you have 2 copies of this sickling hemoglobin gene, you will develop sickle cell anemia. So individuals with only 1 copy, however, have a milder disease and a better chance at surviving malaria. So their cells, if you only have 1 copy of the gene instead of 2, your cells will only sickle under abnormal conditions, one of which would be being infected with malaria itself. So the sickling doesn't allow for malaria to survive. So people who have 1 copy of the gene in areas that are prevalent in malaria actually have a higher chance of survival. So that would be considered a benefit. We also have polycythemia. So this is where we have huge amounts of erythrocytes, and that is not a good thing because it's going to increase the thickness or the viscosity of our blood and cause our blood not to flow as fluidly as it should. So there's something called blood doping. This is an artificially induced polycythemia, and athletes are going to go in, they actually remove some of their blood and then they store it, and then right before an event that they have, they'll reinfuse their erythrocytes back into them so they can increase the amount of oxygen that they have available during whatever event they're performing in. But if you have this high erythrocyte number, it does mean you're going to have a high oxygen carrying capacity, but you're putting yourself at a much larger risk for stroke and heart failure because your blood is so sluggish and thick and the high viscosity. And it's so dangerous that they actually banned it from all competitive sports.